integration architect course. Okay, but it may be extend till 20 day. Okay, so what I have done here, like I created folder structure for each day, whatever we will discuss. Okay, so I will put on this particular folder structure, and then I will upload all this document on Git repository. At the same time, like you will keep getting recording also. Okay, so for recording, like initial 1-2 video will be public, but after that you will get private access for those video. Okay, so let's start from day one. Okay, so in day one, like I have created few content which is very basic for integration. Okay, which you should know before going to in depth of integration. Okay, so our like first topic will be this API-led architecture. Okay, so like first I want to know how many of you have already aware of this API-led architecture, how it works and what all advantage, disadvantage we have. So first I want your thought process, like what you know about API-led architecture. And then I will give you a brief introduction of API-led architecture and what like advantage we have. So like now industry are more like focus on this API-led architecture instead of this monolithic architecture. So can anyone tell me like what you know about this API-led architecture?
Hi Ravi, good morning.
Yeah, hi, good morning.
Good evening, Rajesh here. I think
Yes.
it's like API-led architecture. It's kind of a one style of integration architecture actually. So we have a like three phases of, I mean, three layers we have to go with. So all the layers are being in independently, and we have a system connectors on system layer, so we can integrate with any type of a like we can go with any kind of a database or maybe host or service, any kind of we can easily able to connect. We want to go with any in future also, if we got any extension has been happen, any new database will happen, so we have a existing API specification will be there, so we can easily reusable that asset to some other database and just changing the username and password, and we can utilize those connectors in like Pros API and Experience APIs. And whenever we publish the exchange to Mulesoft, so or it's a reusable connect those API specifications like Microsoft Mulesoft platform APIs are there. It's, we are able to using those APIs in our current scenarios. That's discoverability and reusability.
Yeah, yeah. Yes, so you are correct on this part. Like anything you mentioned, like good only. Like so, anyone else, like anyone want to share a part of like what Rajesh shared? Okay, fine. So now let me give you a brief detail of this API-led architecture. Okay, and then like it will help you in coming classes since we are going to work on this API layer, and we will deal with many things like security policy and many other things where we should have good understanding of this API-led architecture. Okay, so let's start this part. So here, before going to API-led architecture, first we will understand this traditional architecture, what we have this monolithic architecture. Okay, so in this particular diagram, you can see, let me make it full screen. In this particular diagram, you can see we have a application which is hosted on internet, and this application has multiple services. Okay, like product catalog, shipment component, cart component, and order component. And here we have client browser from where client will make a request. And at the same time, we have target system, that is database, where we are either storing data or we are retrieving data. Okay. So in this particular diagram, you can see we have one application. Within that application, we have multiple functionalities. Like our this application delivering multiple functionalities. So If client want to get shipment detail, if he want to get he want to see what all items are there in the cart, and if he want to place the order. So for all those services, they will call this particular API and they will complete their task. Okay. So everything you can see here, all the services are within one application. Okay. And this application will be very, like you can say, big application or huge application where I have written code for everything. Okay. So if we have this kind of architecture where everything is within one application, like all services are available within one application, then this kind of integration or architecture is known as monolithic architecture. Okay. So here you can see, due to this kind of design, we have few advantage also, but we have lots of disadvantage. So what all advantage we have? So first thing, low complexity and easy to deploy. Since this application, everything is within one application. So whenever I want to deploy, okay, so what I will do, I will simply deploy one application on server and done. So we don't have many application to deploy. We have only one application. Simply we will go and we will deploy this application on server. So it's like you can say easy to deploy and time saving process also. But in term of disadvantage, like we have lots of disadvantage, due to which we now every company start following either microservice architecture, or in another way we can say API-led architecture, where what we are doing, we are splitting our piece of coded into separate module, and wherever we can reuse, we are reusing those module to make our like development process very fast. Okay. So in term of like disadvantage, you can say this one is rigid one. Okay. So this entire thing within one application, if you have to do any change, okay, what you need to do, you have to go to this particular application and you will, let's say you want to do change in this particular part. Okay. Since for all services, what all services this API or application will provide, everything is there in single piece, single application. So if you want to do any change, so you have to do change here within same application, and then you need to test all the scenario. Okay, it's not like you did some fix for this particular shipment component. You will only test shipment component where you worked. You have to test all the other application, all the other functionalities also. Due to this change, other functionality are failing or not. Okay. So in this way, you can see like if there will be any change, then entire functionality, entire application will be impacted. Okay. And if due to any reason, let's say you are calling this order component or order services, and there is something wrong with this particular order services, then what will happen? Your entire application will fail. If anything is wrong, then entire application will fail. Okay, since these things are tightly coupled with each other in monolithic architecture. Okay, then as we discussed, like we have single point of failure. As I mentioned, if there will be any error or any code break will happen, then our entire application will be impacted. So there is a single point of failure, and we have slow continuous development. Now, if you want to add anything, okay, no matter we have few services which is already developed, which have similar functionality, you need to write same piece of code again. Okay, since things are tightly coupled and everything is like within one application. Okay, so in this monolithic architecture, like few key points we have. we have low complexity. Low complexity in term of, like here you can see we have single database, okay, where we are connecting with this. Here we are connecting with single database instead of connecting with 2 3 databases. 2 3 database means 2 3 tables and all. Okay, so you will see like in more, like in API-led architecture, complexity wise it will be a bit complex, but we have lots of other advantage which makes that API-led architecture very popular nowadays. Okay, but it's a and it's easy to deploy as we discussed just now. But at disadvantage wise, we have many things like rigid, hard to scale. Okay, if you want to do any change, then you have to test all the scenario since you are going to do change in same application. So if any small change you did, so all functionality are tightly coupled. So you have to test all the functionality, which will take lots of time, lots of effort. Single point of failure, if there will be any failure, then your entire application will be impacted. Okay, and then slow continuous development since things are not reusable here. Okay, if you want to do any development, you have to do from scratch and you can't utilize other existing component. Okay, so like here, like industry like felt like they need something which can overcome all these issues. So we came up with this API-led architecture. Okay, it's a very similar to this microservice architecture where we are like breaking a piece of like a big giant piece of code into small pieces, and then we are breaking in such a way we can utilize the component in multiple places. Okay, so keeping that in mind, here in API-led architecture, we have 3 layers. Okay, we have system layer, process layer, and experience layer. Okay, so first system layer. So this particular system layer interact with external system. It can be any SaaS application. It can be mainframe system. It can be file or FTP system. It can be database. It can be web services. It can be third-party API. So there can be like any external system from where or from where either we are retrieving data or we are inserting data. Okay. So the key point of this system API or system layer to interact with external system. Okay. And here in system layer, we should not apply any kind of business logic. Okay. If we have any business logic, so whenever we are developing any API for any particular services, like there will be like more possibility we will have some business logic. Okay, so if we have any business logic, then all those business logic we will put inside process API. Okay, so in process API we do all the orchestration, we apply all the business logic, and in this process API works as a intermediate between this experience API and system API. Okay, so whenever request will come to Experience API will call this process API, and this process API will apply all the business logic. It will do all the orchestration, and it will call required system APIs. Okay, there can be single system API call or there can be multiple system API call based on the requirement. Okay, and then on top of this, yeah, on top of this, we have experience layer. Okay, now if you work for any organization, there can be multiple experience system for them. Let's say for consumer, they have one mobile application. For their internal staff, they have one mobile application or they have one web application. For like support people, they have some kind of app like concierge app or something. Okay, and there can be web application also. So there can be like in an organization, there can be multiple experience system. Okay. And that experience system may need different set of data. Okay. So for same functionality, that experience system may need different set of data. So in that case, we need different experience API to serve request of different experience system. Okay, let's take one simple example. Okay, so I am working in any banking company. Let's say like take example of any banking company. So they have multiple employee and they have support people also. Okay, now as a employee, okay, like if someone will request for any detail, let's say they want to see their transaction detail. Okay, or let's say they want to check status of their account, that is their account is in active status or not. So if they will ask support people to check that particular account status, then they can go to company like portal. They will open that employee detail. In that employee detail, he will able to see limited information. He should not able to see customer personal information, like what is the gender of that particular person, what is the what is the address of that particular customer. I'm just taking one example, like so whatever like personal data that customer has, so that kind of information is not required for support person. Okay, or you can see, as you can say, bank executive, until unless like they are handling some ticket related to personal information. So here that particular support person retrieving customer information, but he will able to see limited data. He will not able to see customer personal information. So he will able to see what is the status of his account, that account is inactive or active or inactive, when it got active or when it got deactivated. Okay, so those kind of information he will see. But at the same time, if that particular customer or you can say particular user want to see, then he will able to see his personal information also. Okay, so in both the places, they are retrieving customer detail in one place. So that executive person or support person, he can see only limited information related to that customer, but that customer will able to see more detail. It can be in vice versa also, that like customer executive will able to see more detail and customer will able to see less detail. So there that can be in vice versa also. Okay. So here you can see, since we have different experience system and they may need different set of data. Okay. So if we have this kind of requirement, then we develop this different set of experience API. Okay. The main purpose of this experience API to expose our web application to different external system, or you can say experience system. So here, what we are doing, we are just exposing our API to external world having different experience system. Okay. Process layer, we are applying all the business logic. We are doing all the orchestration. All those things we will do inside process layer. And this system layer will connect with external system from where or from where we are either retrieving data or we are sending data. Okay, so it can be database, it can be file system, it can be third-party API. Okay, many things can happen. So let me know if anyone had any doubt in this monolithic architecture and this microservice architecture.
Ravi, I have a question.
Yes.
The system API, we are using DB connectivity and the FTP connectivity, everything we need to do it, right?
Yes.
But here in the system API also somewhere we have to use the business knowledge also, right? the situation when we can use for the system API is considered as a business.
Okay. So first of all, it's a best practice not to use any business logic in system API. Okay. Otherwise, what you are doing? So what is the main purpose of splitting those API into three layers? We want to make this as a loosely coupled. Okay. If you are applying any business logic in system API, what does it means? That system API you developed for any particular business. Okay. In that case, you will not able to reuse this particular system API in another process API. You are designing your system API in such a way it will be used by only particular business scenario. Okay. So here, okay, let me tell you one scenario where we are not applying business logic. We are developing our system API in such a way it will able to serve multiple requests. Okay. Let's say I am developing one system API related to customer information or related to customer detail. Okay. Let me take a notepad. Okay. In customer detail, we have name, we have email, mobile, customer registration ID or customer ID, you can say. Age, age or date of birth, anything should be fine. Just 1 minute. Date of birth, gender, we have this many customer detail. Okay. I want to develop one API which will retrieve customer information. Okay. And I am designing for system API. Okay. Now in system API, we can develop system API. We can plan in this way, first, we will develop one system API which will retrieve customer information slash customer. Resource will be slash customers slash customer ID. Okay, so this API will retrieve okay. Another system API, I want to retrieve customer information. Like let's say we have one in our company we have promotion scheme where if any customer will have birthday, then we on the on the same day we will provide 10% discount for customer. Okay. So in that case also, we want to retrieve customer information. Okay. So we want to retrieve customer information slash customer, and we will pass query parameter date of birth. Now we have requirement of I'm sorry, other API where where I want to retrieve customer information who are living in particular area. Okay, let's say there is some festival in that particular region. Okay, and our company had decided to give offer for that particular region, not for in all the customer. Okay, so here again we will have customer API where query parameter will be address, or you can say zip code or something. Will give offer on based on zip code. So for this API, okay, retrieve customer detail. This one is customer detail API. So for this API, like we will have separate API, but for this two API, okay, here what we are doing, first place we are retrieving customer information based on date of birth. So here we will get lots of customer having same date of birth. And here also we will get lots of customer having same zip code. So what we are doing, we are making these two API requirement specific based on the business requirement. Our business requirement, I want to retrieve customer having date of birth this. Here, I want to retrieve customer detail having this particular zip code. So what we are doing, we are developing our system API requirement specific, or you can say business specific. Instead of doing this, what we can do, we can make one system API where we will provide facility for both the filter. Okay, our system API will support date of birth query parameter also. If we will pass date of birth, it will retrieve customer information having this date of birth. In another case, I want to retrieve all the list of customer living in that particular zip code. So what I can do it, I can club those two API into single API, and where we can provide two query parameter and both will be optional. This is also optional. So if someone want to call our API, okay, and they want only date of birth query parameter, so they will pass only date of birth. And if they want to get customer list of customer based on the zip code, so they will pass only zip code. And if they want both, then they can pass both date of birth also and zip code also. Okay, so here what we are doing, we are developing our system API in such a way it should be independent of any business. Okay, it should able to handle all the business requirement, and it should be loosely coupled also. So is it like answering your question, or you have something in your mind? Chala, are you there? Okay, I'm not sure, I'm not getting any response. Fine. So next.
I have one more question, Ravi.
Yes.
So, in which situation, so I can understand the connectivity, the customer details we can provide in the system API level. So, how we can categorize this happy, pappy, those? in the flow level, API names, how we can find out, how can we provide it. This is
Okay.
SAPI. This is because of I used DB connectivity. That is only
Yes.
one connectivity is for the system API, right?
Okay.
For that, we don't need to create a separate flow for the DB connectivity, right?
Okay.
So in the, how we can categorize to provide our one project, we need to mention as a PAPI, SAPI, like that.
Okay. So first thing, like as I mentioned, in your project, if you have connectivity with external system like database, JMS, file,
Hmm.
FTP, so whenever you are connecting with any external system to exchange data, okay, in that case, you must need to develop system API. Okay,
Yeah.
that system API will be responsible to connect with external system only. We should not put any business logic there. Okay, now
Yeah.
next thing. Do we have any business logic in your requirement? Yes, then you should develop process API. Okay, if you don't have any business logic, simply your like whatever experience system you have, they want direct response without any business logic. Then simply from system API, you will go to experience API, and that experience API will be exposed to external system. So here you need to understand like whatever requirement you have, that requirement need to connect with any external system. If yes, then develop one system API. Do we have any business logic? If yes, then develop process API. Like in your scope, do you have multiple experience system? If yes, then develop experience API. Okay. But what I have seen, okay, it's not mandatory to develop all three layer always. Okay, that depends on your company architecture. That depends on many factor. Okay, still there are many company they are either following two-layer architecture, or there are few company they are following single layer architecture also. Okay, but most of the places you will see like they are following this three-layer architecture. Okay, in simple, whenever you will get requirement, system layer, I will suggest you must go with system layer whenever you are connecting with external system, since that particular system API may be used by many other applications. Okay, and whenever you are getting requirements, you also need to check related system API already existing in your existing project or not. There may be high possibility like that particular system API is already developed by someone. So you need to reuse that system API instead of developing it from scratch. Is it clear now?
Yes, 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 yes.
So here you can see like one example for our API-led architecture, one detailed example. So here we have one system API to get order detail. Another one is to get customer detail. So for customer detail, we have Salesforce as a CRM system. For order detail, we have many things like we have database, we have some third-party API. Okay. And for like ERP system, here we are using SAP system. Then you have for shipment detail, you have third-party system that is UPS. And for toll shipment, again, we have third-party system. Okay. So in this way, you can see like we have multiple systems from where we are exchanging data. So to connect with this external system, okay, we need system API. So here you can see we have 5 system API. Okay. And in this process API, okay, in process API, we are applying all the business logic and we are doing all the orchestration. Okay. So in process API, okay, two things can be happen here. Process API can call single system API. It can call multiple system API. And you can see here process API itself is calling another process API. Okay, this can also be possible. One process API can call another process API. So that's why you have to design your API in such a way it can be reused by multiple other application or other functionality. Okay. So maybe when you will get requirement at that time, it will looks okay. This particular API is only for this particular functionality. Just do it for this particular functionality. But in future, you will realize, okay, the same API we can reuse in other places also if we have this particular flexibility. Okay. So that's why whenever you will get requirement, keep in mind whatever like API you are developing, develop in such a way, as I mentioned, like here. Previously, I had requirement. We had only promotion one. Okay, so what I did, I made this query parameter. I marked it as a mandatory, and I developed this API. Later on, someone in my team only, they are working on this customer customer list API only, and they want customer detail based on zip code. So they developed API based on zip code, and they also marked as a mandatory. Okay, now we can't like even that API is connecting with same database and doing same functionality, but we are unable to utilize in other places. Okay, since we made it, we made that particular system API for to serve only for particular functionality. But after that, I realized and I did change, and now this API is serving like this API is serving both the functionality. Okay, and not only both the functionality, it has more capability. Let's say if I want to get customer detail which are living in that particular zip code, that also we can retrieve with the help of this system API. Okay, so whenever you are developing any API, you should keep in mind that API should be reused in multiple places. Okay, so here we can see like first thing, this process API is connecting with this system API, and connection as I told, there can be one-to-one connection, one process API calling one system API. There can be one process API calling two system API, and there can be possibility process API is calling process API itself. Okay, and then here you can see this experience API is calling this process API, and this experience API is calling two process API. And based on that, it's returning data to different experience system. So this one is returning data to web application, and this one is returning data to mobile application. Here you will get more detailed diagram. Okay, so you can see here we have different experience system. We have one social media, we have one web application, we have one mobile application, or here we have some external system like you can say concierge app or something, and here we have CRM system. Okay, and they have dependency on multiple external system. So here our set of process system and experience API serving their request. Okay, now we will discuss advantage and disadvantage of this API led architecture, and on interview point of view also, like this one is very important. So you should have good understanding of all the advantage what we have with this API led architecture. So first one is loosely coupled. So here you can see, let's say this one. Okay, so in this toll segment, okay, if we want to change this toll shipment from this toll or this UPS shipment from UPS to some any other third party. Okay, instead of UPS, I want to use ABC. Okay, so in that case, what will happen? Only this particular system API will be impacted. Okay, since when this process API calling that system API, all the structure like endpoint, request structure, response structure, everything will be same. Only this system API will update internally, and instead of calling this UPS, it will call ABC system. Okay. Internally, there will be some transformation change, like transformation logic will change. Maybe this UPS instead of UPS ABC system need some different transformation. Their fields name are different. Their response structure is different. But all those handling we will do inside this system API only. Okay. So if there will be any change in this end system, our only system API will be impacted, and this process API will remain as it is. There is no need to change anything in this process API. Okay. Since this process API has connectivity with this system API, and there is no change in the request and response structure of this system API. In worst case, there may be change. In that case, like if functionality itself got changed, and due to that you are changing this UPS to ABS, in that case you may need to change in this process API. But in most of the case, if you are just changing this particular external system, then you don't need to change anything in process layer, anything in your experience layer. Only impacted will be system layer. So here you can see like all those things are loosely coupled. In future, this process API may need some detail from these SAP customers. Okay. In that case, this two system API will not be impacted. Only this process API will be impacted. Even this particular experience API will not be impacted. Okay. So in this way, you can see they are very loosely coupled with each other. If there is any change in any one application or any one layer, other layer is still remain unchanged. They don't have any impact. Okay. Then second thing, increase productivity. Okay. As I mentioned, like here you can see, let me take any one example, this one, order system API. Okay. So initially, let's say we have requirement for this particular functionality, order history. Okay. At the very beginning, I got requirement. I want to see order history. So request will come from this experience system. It will call this web application. It will call this order history, which order history will call this order system API, and it will get data. It will send to here. And after a few days, like we have new requirement where I need to develop order status API, which is again need orders detail from that external system. So instead of calling again this order system API, what this order status is doing, it's calling existing API. Okay. So here what we are doing, we are increasing code reusability. Okay. So this is the first advantage in this particular monolithic architecture. If you see here, so each set of functionality having their own set of code, which is within one application. So we are not reusing anything. Okay. So that particular disadvantage we have here, we don't have any code reusability, but in this API-led architecture, we have code reusability. Second, so same point we discuss here. Previously, we had this order history API. Now we have order status API. So we don't need to do development from scratch. We have existing thing. Let's say we have this also, and we have this customer API also. So this process API, simply it will call this existing customers API and existing order API, and it will get all the required detail, and it will this particular process API will be ready. Okay. So in this way, development will be very faster. Then lower maintenance and operational cost. Okay, this point also we discussed. So here, as I mentioned, if you want to do any change, okay, so only this part of system API will be impacted. All other API, either system or application or experience, will remain unchanged. So here you have very lower maintenance cost. And you don't like not only development maintenance cost, not only development cost, it's a testing effort also. Okay. First of all, you don't need to test all this functionality. Okay. Second thing, you did change, so you will change your particular functionality that is working fine or not. You don't need to do NIT for other functionality which are involved, like where this process API will be involved. Since your request and response structure, everything is same. So here we are saving effort in development, we are saving effort in testing, and it's a faster development also. Since only this part we need to change, no other part will be impacted. Then failure isolation. Okay. So here you can see, okay, let's say due to some reason, this particular, let's say this particular process API stopped working, or this particular system API stopped working. Okay. So if this particular system API will stop working due to any reason, maybe UPS system is down or there is some other technical reason. So only this part of functionality will be impacted. All other part, this part will be keep working. So we order history API, order status API, and many other functionality will be there that will keep working. Only shipment status will have some failure, will be impacted. Since this shipment status is using this particular API and this API has some technical problem. Okay, so if there will be any failure, only limited functionality will be impacted. Other functionality will be keep working as it is. Then granular scaling. Okay, so here you can see, let's say we have some festive season. Okay, and there are too many requests for this shipment status. Okay, so in that case, what you can do, you can do scaling for this particular APIs. Okay, other API, non like we don't need to do any scaling for other API. But in case of monolithic architecture, if you want to do scaling, you have to do for entire application. So you have to do scaling for entire application will be very expensive. Scaling means like now you are expecting more number of requests. Okay, so you need to deploy one more instance of this particular application. Since this is a very heavy application, which need more number of vcode, more number of RAM to deploy. But in this API-led architecture, where we have small piece of application and only this particular functionality need to scale, like this, we have expectation this particular functionality will get more request and we need to do scaling. So only we need to do scaling for this piece of code. We don't need to do scaling for this entire application or this another set of code. Okay, so we have here option for granular scaling. Okay. Is it clear for everyone? If anyone has any doubt, let me know. So we have discussed few points. If anyone want me to explain any point again, so let me know. And this API-led architecture, okay, this one is very important. Okay, whenever you will start thinking about Mulesoft design, Mulesoft architect activity, so first thing will start from API-led architecture only. first you will get requirement. You need to think how many API will be there, what all API will be reused, what process API will do. So first thing will come here, and then we will have lots of things. We will have deployment thing, how we will deploy. Then we will have like what all security policy we will apply. That thing will come in second part. Okay, how you will design your ramal, all those things will come in second part. So first thing will be there, how many API will be there, how they will interact with each other, how we will reuse the existing API. So in that point of view, like whenever you get any requirement, so first thing will be there, how many API will be there and how they will interact with each other. So if anyone has any doubt, let me know.
I am clear, Ravi, in the API-led connectivity.
Okay, then I have few set of question answer. Okay, so let's discuss one by one. Okay, so first I want like everyone input. Okay, what you understood, based on that I need your input, and then I will provide my input. Okay, so first thing, like most of you are working in maybe you are working in Mulesoft project. So I want to understand like if anyone using this API-led architecture. So maybe you can explain a bit about your API-led architecture. You are using all three layer, or you have only one layer, or you have two layer of architecture, and how you are using those API-led connectivity. So can anyone like explain their architecture, how what architecture you have, like how your API-led connectivity works in your organization?
I use warehouse API, the payment add payment section. For add payment section, we require to connect the hub and Sibyl and data warehouse systems. So these three elements we can keep as a system API in the hub connectivity and DB warehouse system and Sibyl connectivity
Okay,
in the
okay.
process
So
API level.
okay,
So
okay. Just 1 minute, like for
yeah,
everyone, like so here you have three external system. One is hub, one is database, and one is warehouse. So to connect with these three external system, you develop three system API.
yes, yes.
Yes, correct. Okay, go ahead.
Okay, so in the payment section, we have different kind of files. Like in the banking sector, we can see Paint 002 version. For example, when you reach to orchestration to channel or orchestration to GPPSP, like global payment placement, like so GPPSP, these kind of environments we can see it. So in that case, we are passing different kind of file formats. Like one is a paint 002, cam 54. These are the common files, right? So in that they are using, when you moving one file from channel to GPP as per our EWA system, there we require the hub requirement. Hub connectivity is required for security purpose. They need the hub connectivity and civil connectivity. These are the required. So when you reach the add payment section from GPPSP to warehouse, in the between them we have passing paint 002 file. In that we have to consider hub connectivity, and hub, if hub connectivity is satisfied, then we can move to the data into DB. So the process, the converting from hub to DB, we have to change the paint 00 version file to paint 003 version 3. In that case, the whole business logic we can write in the processor layer.
Yes, correct.
And the requirement we receive from the client, yeah, that is the EW system, that is from the experience level. That they, like mobile, they want to connect it, or laptop they can connect it, they want it. So that is comes in the experience layer level.
Okay, okay, got it. Yeah, so let me create one simple diagram for this. So what he mentioned, like he has three external system. Let's say one is hub, one is uh, warehouse,
Hub and warehouse and channel civil connectivity something.
let's say database. Okay. So he has these three system, external system. So here, what he did, he developed three system API. Okay. So first system API will connect with this particular system. Then second will connect with this system, and third will connect with this system. Okay. So he has three system API. System API A, system API B, and system API C. Now, as he mentioned, he has some business logic. Okay. To apply business logic, what he did, he created one process layer. Okay. And in this process layer, based on the business requirement, he is calling these three API. Okay. Okay. And on top of this, he has another system API. Okay, sorry, another experience API. Okay, this one is okay. So here, since he has mobile application, web application, to expose their API to external world. Okay, he has created experience API. To apply all the business logic, he has created process API. And process API is calling three system API as there is a connectivity with three external system. Okay, so to connect one with each external system, he has one system API. So this one is perfect API-led architecture he is following in each project. Okay. So anyone else want to like explain your API-led architecture in like API-led architecture your organization is following?
Yes, Ravi. So we also follow API-led architecture. Most of our connection, we connect to Salesforce more than 95%. So what we did is we created one system API for Salesforce. Then for each project or API, depending on the requirement, we create either process layer and experience layer on top of this system layer, or sometimes we only create experience layer, and sometimes we update this system layer based on the logic, but we always have one system layer for this Salesforce.
Okay, okay. So as you mentioned, like some places you have direct system to experience connectivity, no process layer is there. Is this?
Yeah, yeah, sometimes,
Yes.
sometimes.
Okay, so this one is also a very common pattern. Okay, it's as I mentioned, like it is not mandatory to have all three layer. Okay, so sometime it may happen there will be some layer will not be there. Okay, it will be two layer or it will be one layer also. Okay,
Yes,
so
I think it's like it's based on the project requirement and cost cutting all the things, right?
yes,
So if we
yes,
have a huge functionality on that, we go with API connectivity. If it doesn't have that much of functionality and it's that much of request, we go with a one-to-one request only based on the vCode size and allocation, everything.
yes, correct. So that is another key point. Okay, since okay, that question I have already. So any disadvantage of this API-led architecture or not? Okay, so let me cover this question since you already answered. So can anyone tell me like any disadvantage of this API-led architecture? Just now he mentioned that point, but I want like clear explanation of that. What is the disadvantage of this API-led architecture?
It's actually cost bearing is very bit high compared to other technologies.
Yes. So first point will be cost factor. Okay. Since we are splitting our API, our functionality into three layer, and if you know in Mulesoft, if you want to deploy any one layer, you need minimum zero point 0.1 vcode. Okay. Let's say we have requirement of retrieve customer. Okay. Ideally, that retrieve customer system API will be used in multiple places. Okay, that is 100% sure. That particular functionality will be used in multiple places. So we are splitting that into three layers. And how many vCore we need minimum? We need minimum zero point 0.3 vCore to deploy that Mule application. But if we develop that, okay, let me explain it through diagram. Okay. So let's say we have one API to retrieve customer detail. So we are following this API-led architecture. Okay. And here from this experience API, we are calling process and process to experience API to PAPI. And from PAPI, we are calling SAPI. Okay. Now here you can see this is one Mule application, this is another Mule application, this is another Mule application. And if you let's discuss about Cloud Hub. Okay. So in Cloud Hub deployment model, to deploy any Mule application, you need minimum zero point 0.1 vCore. Okay. So how many vCore you need minimum? 0.3 vCore you need minimum. Now, if you realize, okay, whatever functionality you develop, this functionality can be reused in multiple places, then definitely we should go with this API-led architecture, since it will, like for now, it will not give any advantage, but in coming future, when we will start using this API in multiple places, it will give us lots of advantage in terms of like our effort. It will be cost efficient since we will save our development effort, we will save our testing effort, and our like development will be very faster since it takes very lesser time. So your development process will be very faster since you are going to use existing things. Okay. So in that case, this will give you advantage no matter we are spending 0.3 V code, but still we are going to reuse this API in multiple places, so it will give us advantage. In that case, we should follow this 3-layer architecture. Now you have one API. Okay. And that particular API, let's say this API only, like your company scope, your company business, and you identified this particular API will not be reused in any other places. So instead of spending this 0.3 V code, we can develop one API only, one layer only, and we can manage this in 0.1 V code. Okay, so we are saving 0.2 V code, which is very cost efficient. Okay, and like means I don't know exact pricing, but if you take this 4 V code for 1 year or 2 year, it cost around 90,000 USD or something. So you can think this small 0.1 V code also very cost efficient. Okay, very expensive. In digit it looks like only 0.1, but when you go for pricing, it's very cost efficient. Okay, so you need to think first whatever requirement you are getting, is that particular API is going to utilize in any other functionality or not in coming future, or yeah, in coming future it's going to utilize in any other API or not. This kind of API will be used in multiple places or not. If yes, then go with this 3-layer architecture. If no, then you can make it 1 layer or 2 layer. To connect with external system, you can create system API, and to connect with external world, you can create one experience API, or you can develop one process API. Actually, not process API, experience API. And there only in experience API, only you can apply all the business logic. Okay. So is it clear to everyone? Okay. So this second question also we discuss, like, is it mandatory to have all 3 layer in API-led architecture? So answer will be no, it's not mandatory. Based on the business requirement, we have to understand, do we need all 3 layer or not? Okay. So let me give you one more scenario. Okay. I want to develop one API, which is scheduler based API. So hope everyone know what is scheduler based API. So that API will run in any time, means it will run on particular time, whatever frequency we will give or whatever cron expression we will give, based on that API will run. Okay, that those kind of API is known as scheduler based API. So if we are developing any scheduler based API, do we need to create experience API?
No, Ravi, it's not required.
Yes. So that experience API is not required, since we are not going to expose that API to external world. Okay, if we are not going to expose any API to external world, we don't need experience API. So if we have scheduler API, if we have event driven API, okay, so in those cases, we don't need any experience API. Now we have another requirement. Let's say uh, I want to develop one API which will like insert data in order table. Okay, it will insert data in order table, and that particular API we are not going to use, like that particular functionality we are not going to use in any like any other business requirement. That data insert will happen only for that particular scenario. We are like, there is no reusability of that particular API. Okay, and I want to make like that API will be exposed to external world also. Okay, so how many layer we need and what all layer we need? Can anyone tell me? We don't have any business logic here. We want to expose that API to external world, and we want to insert data into database.
We go with the 2 layers of our 2-layer architecture.
Okay, correct. So
One is like it's we can call as a normal pros API, or else we can go with another name, or else system API, and we can expose our system API to external world, and event triggers will be happen from the pros API layer.
this is not event driven. This one is REST API only. I want to expose that API to external world, and we are inserting data into order database.
Okay, then it's two layers is enough, Ravi.
Yeah.
Simple to
So
REST API calls.
yeah, what all layer will be there?
So if we doesn't have any business logic, processing logic, then we go with the experience and direct system layer.
Experience and system layer. Okay, correct. Now I have business logic also, but that particular API will not be reused. Okay, that API is only for that particular business requirement. And I have business logic also. So how many layer we need to develop?
Even if you want require business logic also, we can require the we can write the logic in experience API as per our designing point of view. Even if we not it's a very less business logic, we can write in experience API and send the payload to SAPI. Or else if we heavy we use data and we can write in system API also.
Yes, correct. So here, even if we have some business logic, we can write that business logic in experience layer. Since like that API, like the main purpose of splitting our API led architecture in three layers to make it more reusable. Okay. Since here we don't have any reusability, so we are splitting that into two layer only. And since system layer is connecting with database, okay, so where we have connectivity with external system, we should not expose to external world. Okay. And to expose to external world, we have experience API, and that experience API is directly connecting with system layer. Okay. And if we have small business logic, we can apply that logic in experience layer itself. Okay. We don't need to create additional process layer here, since it will save us, like it will be more cost effective. Okay. Okay, fine. So I think we are good with this question. And anyone has any doubt in this three question? First, second, and fourth? No? Okay. So one question, like here my expectation, like basic things about API, what is RAML. Okay. So third question is based on that. Although like we are going to discuss RAML in detail, but here my expectation, basic thing about RAML. So this third question, do we need RAML for all API or all layer, or we have some requirement to create RAML? Like means there is some scenario where we need to create RAML, or we can create RAML for everything, for all layer, for all API.
Ravi, it's not mandatory to create the RAML for all the APIs or all the layers, but it's a best practice whenever we go with a RAML, because whenever we write the APIs, we are exposing to external world, right? So suppose some other person want to use our API, they have to know what we define, what are the specifications from our inside actually. So that's the reason actually we have to go with the RAML API specifications for
Okay.
understanding the base layer what we define from our end point of view.
And if we have any event-driven API, if we have scheduler API, do we need RAML?
Event driven, that's I'm not sure that's part, Ravi.
Anyone else want to answer this particular question?
So Ravi,
Yes, go
Sorry.
ahead.
on
Yeah,
yeah.
Diti, go
So
ahead.
okay. So we only need a RAML for REST API only. We don't need a
Yes,
RAML for scheduler or event driven.
yes, correct. So whenever we are developing REST API, only for REST API, we need RAML file. Okay, so by name only, like it's a RESTful API modeling language. Okay, where we define the behavior of our API, behavior of our REST API. Okay, so first you need to identify, is this REST API or not? If that is REST API, then we should create YAML file. Again, it's not mandatory. If you will not create YAML file, still your technically your API will possible. You can develop API, but it's a best practice. You can say we should create YAML file since it tells behavior of our API. So who all are going to consume our API through YAML, they will able to understand what is the behavior of our API. Okay, and if your API is scheduler based API, since that is not, that scheduler API will not be called by any external system or any experience layer, that will be auto triggered. So we don't need to expose the behavior of our API. If it is event driven, like whenever data will come in database, our API will be triggered. So this kind of API is event driven API. So if there is such kind of API or some listener API, like where some, let's say there will be data in JMS queue and then our API will be triggered. So those kind of API, no need to like expose to external world, and there will not be any user who are going to consume that API. So for those kind of API, we don't need YAML file. Is it clear now? Okay, fine. Now last fifth question we have. Okay. So if I want to make two-layer architecture, okay, then like as per your understanding, which layer we should remove? Okay.
Yeah, I,
Okay.
may I?
Can I? Okay. Sorry.
Yes, yes, go ahead.
Yes. So we will remove process layer, and here system layer is compulsory, and the logic of the process layer will be written in experience layer.
It's not correct. Anyone else want to answer?
Okay. At my company, hi, this is Divya, and
Yeah.
our company we are doing it as a system and process layer because system layer, as you said, or is anybody's know that we are connecting to the source system, and in the process layer we can keep the logic and we can use the experience API as well as a process.
Okay. Okay. Yeah. Here. Okay. Anyone else want to answer? No. Okay. So first thing, like whenever you want to make two-layer architecture, okay. So first thing you need to understand what kind of API you have. So system API, I will suggest you must go with system API. You must need to develop system API. Now coming to process API and experience API, you need to think here. Okay. So what kind of API you are going to develop? Are you going to expose your API to external world? In that case, you should create system layer plus experience layer. Okay. And whatever business logic you have, you should put in experience layer. If you are going to develop scheduler based API, in that case, you should develop system layer plus process layer. Okay. So that you need to see first, like what kind of API you are going to develop. And based on that, you can decide you need system layer plus experience layer or system layer plus process layer. Is it clear to everyone?
Yes, yes, Ravi.
Yeah. Okay, fine then. So what we will do, we'll take a 5 or 10 minute break and then we will start again. So let's connect in 10 minutes.
Okay.